Hey guys, in this video I'm going to show you about the process of triangulation. This is how we locate an earthquake's epicenter. It all begins with being able to find the S and the P interval. So in the activity you were given these 5 seismograms, and in each one there's an S wave and there's a P wave. Remember that the P wave is faster, so this is your P wave time and this is your S wave time. That's going to be the same in every single one of these seismograms because the P wave is always faster than the S wave, so it will show up first in a seismogram. Now that we know which one is the S wave and which one is the P wave, we can go ahead and find the S and P interval. Remember, this is called the S and P interval for a reason. The S wave is always a larger number. The P wave is always a smaller number. So I'm going to subtract the P wave from the S wave every time, and that way I don't wind up with a negative number. Let's go ahead and get started. I'm going to go ahead and write down the S wave time, and then I'll write down the P wave time, and we'll go from there. So the S wave time is 5 hours, 58 minutes, 0 seconds even. And the P wave is 5 hours, 54 minutes, 40 seconds. We run into our first problem right here. If I subtract 40 from 0, I'm going to go negative 40. So in order to solve for that, what I'm going to do is I'm going to borrow a minute from this 58 right here. When I borrow a minute from it, it becomes 57, and I'm going to add the 60 seconds right here. When I add those 60 seconds, I have 60 plus the double 0. I now have 60. This no longer exists. And 60 minus 40 is 20. Then I'm going to take 57 minus 54, and that's 3. We have 3 minutes and 20 seconds. I want this whole thing in seconds. These 3 minutes right here are 180 seconds. So I'm going to take the 180 seconds, and I'm going to add those 20 seconds that are left over for a grand total of 200 seconds. So the SP interval for Phoenix, Arizona is 200 seconds. Now I'm going to go through and I'm going to quickly do the other ones.
This song is 1 minute long. 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 It's about 1 minute long. It's about 1 minute long. It's about being 1 minute long, and it's almost exactly 1 minute long. This song is 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 1 minute long. All right, how we doing now? We got how much time?
20 seconds.
Yeah, doing pretty good here. One more thing to say, probably, if I can think of something. All right, yeah.
11 seconds.
Yeah, okay. This song is 1 minute long. 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 Nailed it.
All right, now that we have our S and P interval, which is right here in this column, and I just used the S waves and the P waves on the previous seismograms to help us find that, what we're going to do is we're going to find the distance to the epicenter. In order to find the epicenter, we're going to use our seismic wave graphs and the S and P intervals together. So here's what it's going to look like. All right, now that we have our S and P intervals that we calculated using our seismograms, we're going to go ahead and find out the distance to the epicenter using the seismic wave graph. Really quickly, when we take a look at the seismic wave graph, we're going to notice on the y-axis we have time in seconds. On the x-axis we have distance in kilometers. Here's P wave, here's an S wave graph, and the difference between them is an S and P interval. In order to find the distance, all we have to do is find the S and P intervals that we calculated right here, and that will lead us to our distance down here. So to help us find the distance from the epicenter, I'm going to use these little slips of paper. And you'll notice a couple things. Number one, I folded over on the line where it says fold. And number two, I've already marked on the slip of paper 158 seconds. Why 158? Because that's the S and P interval for New York. So there's 158 seconds, which is the S and P interval for New York, marked off right here. And all I simply want to do is find a place where these two lines are separated by 158 seconds. So I'm going to put the 0 right here on the P wave line, and I'm just going to move this until it matches. And here I am, there's the 0, and it's right on the P wave line. There's the 158, and it's right on the S wave line. And I'm going to bring it down right here to the bottom, and notice that that's at 1,200 kilometers. Each one of these boxes is 100. So that's 1,200 kilometers. That means the distance for New York is 1,200 kilometers. Now I'm going to do the same thing for Louisville, which has an S&P wave of 51 seconds. So if I take a look, I have my little slip of paper. I've marked it off at 51 seconds already. I'm going to bring it down to bring the 0 to match the P wave. There's where the 51 is matching the S wave. I'm going to mark this distance, and that distance is one box shy of 500, or it is 400. I'm going to quickly go ahead and do the other ones. I'll mark the times in the worksheet as I go along. Now that we have our distance to our epicenters in kilometers, what we need to do is be able to fit this on the map. We're going to go ahead and convert this to centimeters. And we're going to do this by dividing each number by 200. Why? It's the scale that I'm giving you, but also on the map that we're going to go ahead and plot on, it says the scale 1 centimeter is equal to 200 kilometers. So all I need to do is just divide by 200. So what that means is this 400 turns into 2 centimeters, 700 turns into 3.5 centimeters, 1100 turns into 5.5 centimeters, and 1800 turns into 9 centimeters. Now don't worry if you got a half a centimeter off or so. That just means that your numbers were off by 100 or so, and that's okay, because using that S&P chart graph, this seismic wave graph right here, it's easy to get off by 100 or so. So no big deal if you're off by a little bit. All right, we're on the final part of this activity, which is to triangulate the earthquake or find the epicenter on a map. To do this, we need some things. We need a sharp pencil. We need our distances that we calculated earlier for the map scale. We need our map right here, and we also need a compass. When we take a look at this compass, you'll notice that there's a couple different parts to it. There's inches down here and centimeters up here. Make sure you measure everything in centimeters. Notice that there's a little blue knob right over here. And with that blue knob, what that allows you to do is it allows you to turn and loosen and slide to whatever measurement that you want. And then you turn it to the right to lock it in so it doesn't move. Here's the little part where this will go to the center of each city, this little blue circle. You can kind of see a little crosshair right there in the middle of it. That little plus sign right there in the middle, that's going to go right on the dot of each city, and we're going to plot the distances from there. So here's our map, and the first city we're going to plot from is New York, which is right here. And we need to plot from New York. We need to plot that. I didn't do that distance. 1,200 divided by 2 is 6 centimeters. We're going to plot 6 centimeters away. Now, in order to do that, I'm going to take the compass, and I'm going to set it for 6 centimeters. I'm going to loosen it up. I have 6 centimeters right here. So I'm going to make sure one of these two holes is on 6 centimeters. It doesn't matter which one. I'm going to put it on. I'm going to hold it. I'm going to tighten it so it doesn't go anywhere. I'm going to put the center of this little dot right here on New York as best as I can. Then after I have that middle there on New York, I'm going to make sure I'm going to 6 centimeters, put my pencil in the hole, and simply just spin to make a circle. Now what this is saying is this: earthquake waves travel in all directions, and what that means is if the earthquake happened 1,200 kilometers away from New York, it could have occurred anywhere along this line that we just drew. We don't know where. We know that it happened some 1,200 kilometers away, but we don't know exactly from where it happened. So what we have to do is we got to draw a few more circles. And wherever the circles intersect, that's where our earthquake could have been. Now, I got to be honest, if we're looking at this activity, the scaling of the map got a little bit off as we made copies and stuff like that. So the circles may not match up perfectly. But as long as you get the idea, that's okay. The next one that I'm going to do is I'm going to do Louisville, Kentucky for 2 centimeters right here. So I'm just going to loosen. I'm going to tighten up at 2 centimeters. I'm going to find Louisville, Kentucky, which is right here. I'm going to put the compass as best I can right on Louisville. And I'm going to draw my circle around Louisville. Now, we have a couple of options as to where the earthquake could have been. Again, Louisville, they felt the earthquake. They don't know where it came from because earthquake waves travel in all directions. So it could have happened 400 kilometers or that 2 centimeters anywhere on this circle. But since New York felt the same earthquake, maybe the earthquake happened where the circles intersected. Let's find out. Let's go ahead and do the Green Bay one, which is 3.5 centimeters. So here's my compass set at 3.5. I got Green Bay right here. There's the dot for Green Bay. And I'm just going to make sure I'm on the right one. Drawing my circle. All right, so now we got another couple possibilities. Remember, the earthquake is going to be wherever the circles intersect. So the earthquake could have happened here. It could have happened here. It could have happened here, here, or here. So we need another one. We need a third one to cross over. Let's take a look at Pueblo. Pueblo was 5.5 centimeters away. So I'm going to go to Pueblo, Colorado, put the compass on there as best I can, and I'm going to trace out 5.5 centimeters. Now if we take a look at what's happening. We have 3 circles that are nearly crossing one another. I bet our epicenter is right there. This is the best place where 3 circles are coming close to one another. Let's go ahead and plot out Phoenix just to be safe. Phoenix is 9 centimeters away, so I'm going to put this right there on Phoenix, and I'm going to go to 9 centimeters right here. And Phoenix doesn't really cross with any 2 others. I mean, it's kind of a lone one out there. So I think the best one where all 3 cross are right there. And that is the epicenter for our earthquake. So let's go ahead and do a quick review. You're going to use the seismograms to find the S&P interval. You're going to use the S&P interval to find the distance to the earthquake using a seismic wave graph and also using these little slips of paper. After you found that distance, you're going to plot that distance on the map using the compass and the distances that you found earlier. And wherever all 3 best match, wherever you have 3 circles best match up, that is where the epicenter for the earthquake is going to be. Please let me know if you have any questions about this process in class.